In this lesson, we're going to be talking about midsegments of triangles, and we are going to be using properties of midsegments to go ahead and solve problems. So in order to do that, we need to talk about what a midsegment is. And a midsegment is a segment that connects the two midpoints on two sides of a triangle. And these midsegments have some special relationships in the triangle. So our first theorem is called the triangle midsegment theorem, and basically it says if you have two midpoints, then the segment that connects the two midpoints, in this case we have midpoint D and midpoint E, and this segment DE is called a midsegment, and what happens is DE ends up being parallel to AB, okay, the side that is not, doesn't have any of the midpoints. So DE ends up being parallel to AB. And the length of DE also ends up being half as long as the segment AB. So if you wanted to prove why the midsegment theorem works, you would have to prove two things. You'd have to show that DE is parallel to AB, and you'd also have to show that the length of DE would be half as long as AB. And we're going to go ahead and do that for this particular example here, where we have a triangle with vertices A, B, and C that are given. So we're going to show that DE is parallel to AB, and we're also going to show that DE's length is half as long as AB. So we've already learned about parallel lines, and we know that parallel lines have the same slope. And we also know how to find the midpoint. So our first step is to find the midpoint. What are the coordinates of D and what are the coordinates of E? So we would do that by finding the midpoint of segment CA. Well, C is at 0, 0. And A is at 4, 6, so the midpoint of CA would just be the sum divided by 2, so we get the coordinates of D is 2, 3. And likewise, the coordinate of point E would be the sum of 0, 0 plus 6, 0, and we end up getting 3, 0 for the coordinates of E. So now that we have those coordinates, we can go ahead and use those to find the slope of the line containing D and E. So the slope of AB, we'll go ahead and find the slope of this line, AB first, and that's rise over run, y2 minus y1 over x2 minus x1. We've used that quite extensively. And the slope of AB turns out to be negative 3. Then we can find the slope of DE. Remember DE, we found its coordinates here. So we're going to do rise over run with that as well, and that turns out to also be negative 3. And you know that if you get the same slope, that means that the lines are parallel. So those two segments are parallel. So we've proven the first part. So the second part, we just need to prove that DE is half as long as AB. And for that, we're going to use the distance formula, which you are familiar with. And for segment AB, if we plug in the coordinates of A and the coordinates of B into the distance formula, we end up getting 2 square roots of 10, which in decimal is about 6.32. So if we do that for DE using the coordinates we have for DE into the distance formula, we get 1 square root of 10. And we can obviously see that AB is twice as long as DE in radical form. If we found the square root of 10 works out to be 3.16. So it is definitely half the length of AB. So here's a problem, and it says, what are the 3 pairs of parallel segments in triangle DEF? So we have the big triangle DEF, and we want to know what are the 3 pairs of parallel segments. Well, we know that R is the midpoint of side DE, and S is the midpoint of side EF. So the midsegment RS, RS is the midsegment of the triangle. So from our triangle midsegment theorem, RS would be one of the segments that's parallel, and it would be parallel to DF. Another side that would be parallel, we could have, since S was a midpoint and we also have T as a midpoint, then ST is a midsegment, and ST would be parallel to DE. And lastly, we have, since T is a midpoint and R is a midpoint, the segment RT would be a midsegment, and it is parallel to EF. So here's another problem for you to try. In triangle XYZ, A is the midpoint of XY, B is the midpoint of YZ, and C is the midpoint of ZX. What are the 3 pairs of parallel segments? Well, you can't do anything with this unless you first draw a picture. So I went ahead and constructed a picture for you to draw. Feel free to copy this one. And it meets all the requirements of what was just listed. So if we want to know what are the three pairs of parallel segments, well, we would have the midsegment AC would be parallel to YZ. We would have, and that's kind of a messy A there, sorry about that. We would have side BC, or midsegment BC, is parallel to YX. And lastly, we have, let's see, I have AC, we have BC, we would need AB in there is the one that's missing. AB would be parallel to the side XZ. So those are our three sets of parallel segments. And I should have segment signs over all of these. Okay, so the second part of that question says, what is the measure of angle VUO? So VUO, they're looking for the measure of this angle right here. And we're wondering what the measure of that angle is. Well, from the drawing, you can see that U is a midpoint of NO because they have indicated in the drawing NU is congruent to UO. That's what those little dashes mean. And V is also a midpoint because MV and OV are congruent. So segment UV is a midsegment. You can't assume that unless the drawing shows you that they are midpoints. Then you can assume it's a midsegment if these are both midpoints. So segment UV is a midsegment. So since we know it's a midsegment, we know that it's parallel to MN. So MN and UV are parallel. So the relationship here, if we have two parallel lines, the angle VUO and angle MNO, the 65-degree angle, are corresponding angles because of the parallel lines. So we know that it would be 65 degrees because they are corresponding angles. All right, problem number 2 says we have triangle QRS and they give us three midpoints. What are the lengths of TU, UB, and QR? Well, we'll start out trying to find TU. Well, TU is this midsegment and it will be half as long as SR. So we already know that SR in the figure is given as 40, so the length of TU would be 20. Likewise, if we're looking to find UB, it's going to be half the length of QS, and QS is given to us as 50, so that one will be 25. And TB will be a little bit different. So TB we're given, okay, TB is 30, so it's half as long as QR, so we want to find the bigger one this time instead of the midsegment. So let's plug in what we know. TB is 30. We're looking for QR, so we multiply both sides by 2, and QR works out to be 60. Okay, here's one for you to try. Go ahead and pause the video, see if you can come up with these 4 segment lengths, and I'll give you your answers when you get back. All right, I hope you gave those a try. Let's go ahead and take a look. We know that AD is 6 and DE right here is 7.5, and we want to find the lengths of these segments. So first of all, they say, what's the length of DC? Well, it's marked in the figure that AD and DC are congruent, so therefore the length of DC must be equal to AD, which is given as 6 units. How about AC? Well, AC is the total distance. If we know DC is 6 and we know AD is 6, this one has to be 12. So we just double that. And then we want to find the length of EF. Well, EF is the midsegment, and if this segment AC is 12, then EF has to be 6 because it's a midsegment. And you can notice from the drawing that it is a midsegment because CE and EB are congruent and AF and FB are congruent. So we know that both F and E are midpoints. So we know EF is a midsegment. If that were not the case, we could not find this. Okay, how about AB? We want to find the length of AB. Well, they tell us that the length of DE is 7.5. So because we know DE is 7.5, then AB has to be twice as long. So that would give us a length of 15 for AB. All right, this problem says a geologist wants to determine the distance across a sinkhole, and that distance across is segment AB in the triangle. So he chose a point outside of the sinkhole, point E, and measured off those distances, AE and BE, and then found the halfway mark, okay, the midpoint, C and D, so that we have mid-segment CD. So she was able to measure segment CD and found that that was 46 feet. So what is the distance across the sinkhole? Well, since CD is a midsegment of the triangle, we can use the midsegment theorem, which says CD is half the distance of AB. And we know CD is 46, so all we have to do is multiply both sides by 2 and we get 92. Here's a very similar problem. Go ahead and pause the video, try this one on your own, and I'll give you the answer when you get back. All right, hope you had a chance to try that one. Let's take a look. So it says CD is a bridge being built over a lake. What is the length of the bridge? So we want to find the length of CD. First of all, we need to know that C and D are midpoints, and in the figure they have indicated that D is a midpoint, and then if you look at on the other side for C, both of the sides of there, both of those segments are congruent. So CD is in fact a mid-segment. We also know the distance across here is 2,640 feet, so CD is a mid-segment, so we can just take half of 2640, which gives us 1,320 feet. And that's what CD is equal to. All right, here's your lesson check. Please have this ready to hand in when you come to class tomorrow. We'll see you next time.